using AI and sensor technology. So, title of today's talk is AI application in physiological and pathological states, classification using EG signals. So, in this talk, objective what are the technologies are available, how you can develop your AI-based system for any physiological and pathological applications. There is a basic motive how you can start your work, how you can think, how you can start your research on this direction. So that is the objective. If you have any question, you can at the end you can ask any question. So we will have a discussion at the end of this talk. So what I am going to cover in this talk, introduction of and AI in biomedical. Then we will talk about the computer-aided diagnostic system, how you can develop these systems. Then I will take two examples. One is the emotion classification. Second one is the classification of schizophrenia. Then conclusion, then references, then what is the current research for going on this direction. So these are the overview of the talk. So as you know, nowadays healthcare is a very essential and highly sector which is growing faster than the economy. And many places in the healthcare sector we require to process information. Either we are talking about the screening, diagnosis, monitoring tasks, or managing a healthcare sector. So many places we require to take a decision or to process that information. So whenever you need to take a decision, so without any human intervention, if machine and computer are capable to solve any problem, or instead of human brain, the machine will take the decision on the behalf of human brain. So that is known as AI. Okay. So what is the benefit in AI to use in the healthcare sector? It can retain the information. So suppose you are using AI system, so it will retain the long-term information. Second is it does not have smart over the time. So once the new variant of the disease or new information will come, so based on the new information, you can improve your system based on feedback. Okay. Then machine does not have a susceptibility to deprivation. If suppose some work is repeatedly, so it does distraction, information overloading, and short term. These are the advantage of AI. Okay. What are the benefit of AI in healthcare? So one, clinical decision making. So better clinical decision can be taken. So as we always talk about the second opinion. So the machine will help, AI system will help for better clinical decision. Okay, and it can be up to date by some latest journal, latest clinical practices. Based on that, some new information can be easily processed. It will solve the problem of experience and plus clinician because if data is diversified and it has covered all aspects, then this problem can be solved. AI system can be available for 24 by 7. Availability of the expert is important. Early diagnosis is possible. Prediction of the outcome disease as well as the treatment. Based on the treatment can be improved. It can reduce the diagnostic and clinical error. So these are the few benefits that I have listed here. If you talk about the computer-aided diagnostic system, so around the globe the market is growing rapidly. And if we talk about the AI-based diagnostic system, so size is 1.3 billion. It is expected in 2026. So there are three different type of aspects in computer-aided diagnostic system. One is known as services, software, and hardware. So all three directions, the market is growing rapidly. So how you can develop some biomedical signal classification based system? So first is data acquisition means which problem you are encountering. Based on the problem, you have to acquire the data. Okay, suppose you want to develop the system for any diagnosis of any disease or any physiological condition. Physiological condition means which does not contain any disease. So you can develop some AI-based system. So for that you require database. Okay, and how the database you can acquire? So first, which problem you are encountering. Based on that, which organ of the body is affected. Okay, suppose for example, you want to develop the system where you can identify the heart failure. So for heart failure, which particular organ is affected? Heart. So heart related data you have to collect. Clear? Suppose somebody having a sleep related problem. So sleep related problem is directly related with the brain. Then the brain related data you have to acquire. So based on the problem, there are several biomedical signals are available in the body. So based on that problem, you need to identify which particular organ is affected, and based on that, you need to acquire the data. Clear? Suppose you are working on a disease for gesture recognition, so then you can go for EMG signal if it is related with the muscle signals. So based on that, you need to identify data. Clear? So the problem is if you are working in the physiological state, so physiological means which does not contain any disease. So the database you can take from the some benchmark database, or physiological you can develop your own data. Okay, by taking the ethical approval from the your institute committee. Physiological means which does not containing any disease, which is the physiological phenomena like emotion classification, stress recognition, hand movement, leg movement. If you want to develop some brain computer interface for game theory, then these things you can develop your own data. Clear? If you are going for diagnostic purpose, then you have to take a data from some hospital. Clear? Because the patient you will get in the hospital. So what you need to do, you need to collaborate with the hospital, then take ethical approval, then you can collect your databases. Otherwise, if you are encountering such problem where the database is already available with benchmark database, so that database you can take. Clear? Now, after getting database, what you are going to do, you need to apply signal processing technique. So what signal processing techniques is going to do? Signal processing technique will convert your data into a meaningful form, where you can acquire more information. Clear? So how the signal processing technique works? So you can see here. So there are several signal processing techniques. Like here, some of them I have listed here. Like fast Fourier transform. So fast Fourier transform will give you the frequency domain. Here, STFT is the short time Fourier transform, which will give you time frequency distribution. Means you can find out what frequency components are present in the what time domain. Clear? So time frequency information you can extract from the time frequency by using STFT. Wavelet transform. So wavelet is multi resolution property. So if you are using discrete transform, then DFT will compose your signal into different bands. Clear? And continuous wavelet transform will represent your time domain signal into time frequency domain. So now after that, signal processing techniques are having a two parts. One is known as decomposition, second one is known as time frequency representation. So in decomposition, what you are going to do, you are decomposing your signal into different frequency bands. Then you need to find out which particular band is responsible for that particular activity. Okay, so then you can discriminate these classes. Okay, so what signal processing technique is going to do? Signal processing techniques will convert your signals such a domain so that you can extract more information. Clear? It also reduces the complexity of your system. Clear? So like EMD is the decomposition method, TQWT, FAWT, variational mode decomposition. So these are decomposition techniques. So now first you need to decide whether you go for decomposition technique or time frequency representation. Clear? So based on that you need to select the signal processing techniques. Clear? Now after that, once you have converted your data into different domain or representation, then you need to extract features. So features extraction process, features means within the group they have a same attributes, but out of the group they have a discrimination or they have a different attribute. Then you can say that features have capability to discriminate these classes or group. So the selected features you can select the features by using some statistical test. Like for two class you can go for ANOVA test, which is known as Kruskal test. For multi-class classification problem you can go for post-hoc analysis. Okay, then we will see in the detail in next slide. Then the last is known as classification or machine learning algorithm. So there are several machine learning algorithms are available. Like initially they have divided into two parts. One is known as supervised, second one is known as unsupervised. If you are working any healthcare related problem, then unsupervised methods are not used. Supervised method means you already know the class, which particular signal is belonging to which class. So you already have that information. So these are known as supervised method. So some of the supervised machine learning methods I have listed here, like decision tree, Naive-Bayes classifier, Bayesian classifier, support vector machine, LDA, perceptron-based classifier, KNN. Till now, there is no method which can tell you which particular classification strategies are better because they depend on the data, what type of features you are taking, and what problem you are encountering. Okay, so depend on the classification accuracy and system performance depend on the your classification strategy as well as the features as well as signal processing technique. So till now there is no method which can tell. So every time you experimentally you have to find out which classification strategy is good for your data. Okay? Suppose sometimes suppose vector will give better result, but sometimes you have to make some other method can give the better result. The reason because the classification strategy depend on the features and features are depend on the signal processing techniques. So these are interlinked. So every time experimentally you have to find out which classification strategy is more better for your application. Clear? Now, so this is the basic building block. Now I am taking two examples. So like here I am taking example of EEG signal. So EEG is the measures the electrical activity of the brain generated by the neurons. So it investigates different pathological as well as the physiological states of human brain. With pathological means that particular stage containing some disorder or disease. Physiological means which does not containing any disease like emotion classification, brain computer interface. So these are come under the physiological stage. So the quantitative analysis of EEG signal is very challenging because it has an irregular nature, non-stationary nature. So visual scanning of EEG is very challenging because it's time consuming, inaccurate, complex. Sometimes it's subjective judgment, human error, but it will also trained by it will be performed by the trained professionals. So that's why visual scanning is very challenging. So what is the requirement? Now we need to develop some AI or machine learning based system where we can interpret that class and we can physiologically we can understand how this particular stage is changing. So here I am taking an example of emotion classification system. So here I have developed one automated emotion classification system. So what I have done some experiment. In this experiment, I have shown 12 videos. For 4 different groups I have taken like sad, fear, relax and happy. Each group having 490 signals and for that 20 subject I have taken as a for recording purpose. Here, so what I have done, I have shown blank screen, then audio video is only I have shown, then blank screen, then audio video is only. So this way we have done our experiment. Then we have acquired the signals. So why I am taking 4 different groups? Because in AV model they are in the 4 different domains like happy, relax, sad and fear. They are lying in the different quadrants. So this is the database. So what is the problem here? Which particular portion of the brain is responsible for emotion classification? This is a big problem. So that we need to identify. Second, the sampling frequency was 256 Hz. So which particular portion of the brain is responsible that we need to identify and which method we should apply. Clear? So what I have done here, so this is the brain mapping. So what we have done here, we have used bipolar longitude montage. What do you mean by the montage? So this is the brain mapping by using 1020 system. So what you need to do? Suppose you are mapping a brain. So what you need to do? You have to take this is the nation. This is known as canyon. So what you need to do? You need to take a distance of this peripheral of this. Clear? Then suppose the peripheral is 26 centimeter. So what you need to do? You need to find out the 10% of that. 10% is 1.36. Suppose this is 26 centimeters. then 1.3 will be, you will get this point FP2. From this position to this position, 10% you will get FP2. Then after 20%, F8 you will get. Suppose the peripheral is 26 centimeter, then FP2 you will get in 2.6 centimeter. Then the distance between FP2 and F8 is 5 point. Clear? So this way you need to map your brain. So F is denoted frontal region, C is denoted by the central region, T is denoted by the temporal region, O is denoted by the occipital region. Clear? If you are taking a potential difference between that particular electrode with respect to EF, then that is known as monopolar. Okay? Bipolar means I am taking a potential difference between FP2 to F4. Means the potential difference of FP2 and F4 will be your budget. Clear? So that is known as bipolar longitudinal recording. Clear? So there are three different type of montage people can use. One is known as monopolar, one is known as bipolar, third one is known as reference. So which particular recording you need to use? So either you can experimentally you can find out, or by using literature you can find out the activity you are going to find out which is responsible for which type of montage. Clear? So like for emotion I will find out bipolar is more suitable. So what we have done, like you can see here, the recorded signal by visual scanning, it is very difficult to find out which is belongs to the hemisphere, cell and neutral. Clear? So that's why we need to develop some algorithm, so that automatically we can identify. So what I have done here, I have used ENT-GMD algorithm for classification of emotion. So ENT will give you the decomposition. Clear? So it will decompose your signal into a different frequency band, which is known as intrinsic mode function. Clear? So what we have done, when we have seen a data, then it has a noisy component. So what I have done, based on this IMF, I have developed some correlation criteria to remove the noisy IMF. Clear? So if the threshold of the signal is less than the threshold of that particular IMF, then it is noisy. If it is greater, then it is not a noisy signal, noisy IMF. So noisy, based on this information, we have reduced the noisy component. Clear? So based on that, we have removed the noisy IMF. Then we have reconstructed signal. So this reconstructed signal having a higher SNR comparatively to your original signal. Then what we have done, we have applied VMD algorithm, because in this signal the frequency component is available which is more than 60 Hz. But our requirement is 0.5 Hz to 60 Hz. So what I have done, I have used VMD algorithm to filter our signal, so that unwanted frequency component from 0.5 Hz to 60 Hz we can remove. Less than 0.5 Hz or more than 60 Hz frequency component is not useful for us. So what I have done, I have used filter 0.5 Hz to 60 Hz. Then reconstructed signal. So this is our reconstructed signal which containing only the frequency component from 0.5 to 60 Hz. Then we have applied several type of features. Then we have applied S-score, or just I will tell you some next slide how we can select the features. So this is known as signal processing techniques. So what we have done from the signal processing technique, we have removed the noise, and what we have done, we have filtered out the signal for 0.5 to 60 Hz frequency component. So that is the work of signal processing technique. Okay. Then we have extracted features. So just I will tell you. So like here, you can see this is our original signal. So after denoising, it will look like this. So you can see high frequency noise has been removed from the original signal. Now, if you see the spectrum, so this is original signal. After the first step, when I have applied the correlation criteria of PMD, then it will look like this. So you can see here high frequency component has been removed, but still the frequency more than 60 Hz frequency is available. Then after BMD algorithm, this is our desired signal, which does not containing any noise and which has only went from 0.5 to 60 Hz. So by this spectrum you can see our method is signal processing method is work. Now, after that I have extra features, so like sample entropy, Taylor's entropy. So these four features are used as a machine learning, used as an input to machine learning. So how I have find out these features are important. So what I have done, I have used this F score for each features and each electrode. Clear? So like previously I was having a 16 electrode. So from each electrode I have found out these features. Then I have calculated this F score. So if F score you can see here for F7 or F7 channel, F score is higher in all four features. You can see here. Clear? For other the F score is less. So based on that F score we can select the feature as well as we can go for channel selection. Which channel is used? So initially I was having a 16 channel. Based on this method, what I have find out only one channel which is F1 and F7 is more useful for us. So it has reduced the complexity of the system. Clear? This is post-hoc analysis. Based on that we have selected features. So like here you can see, this is the distribution for happy class in sample entropy. So you can see sample entropy has capability to discriminate, fear, sad and relax. But in sample entropy there is some feature, some signal is they have a common correlation. You can see here. So they may provide a misclassification if you use sample entropy. Clear? Same in terrace entropy also, the all three groups having a common attributes but happy having a different. So this way you can select features. So this is known as post-hoc analysis. Clear? You can find out multiple features. You can say that I have 100 features, so you can go for 100 features. But the selected, if you have a more features, then the complexity of the system will get enhanced. So you require to take a decision. So based on that post-hoc analysis, F score, you can select important features for your system. Clear? Once you have selected these features, then these features you can use as a input to machine learning algorithm. So how the machine learning algorithm works? So like these features you can use as a training set. So like initially I have 490 signals. From each signal I have acquired 4 features. So now my matrix size is 490 cross 4 for each class. Clear? 490 cross 4 for happy, 490 cross 4 for sad, 490 cross 4 for relax, 490 cross 4 for fear. Then these are known as input training set. Clear? That we will give as an input to machine learning algorithm. What do you mean by the output training set? Output training set means this is the multi-class classification problem. So what I will do, for one class I will represent by 1, second class I will represent by 2, third class I will represent by 3 and fourth class we will represent by the 4. Clear? So this features we will give as an input to machine learning. So like here I am taking example of LSS. Then you have to select some kernel parameter and its kernel function and its parameter as a input. So these are known as machine learning algorithm. Clear? So the training, these two things we need to do. One is known as training, second one is known as learning, third is known as for testing. Clear? Training means you are training your machine learning algorithm. Clear? Validation means or learning means based on the training it will give a hyperplane. Hyperplane means boundary. Based on that boundary, if you apply the testing data, then this machine learning algorithm will tell you that particular class is belongs to which particular group. Yes, so that is known as testing. So training, learning or testing, these are the three parts of any machine learning algorithm. Clear? So like here I have used 10 cross validation. So in 10 cross validation, whole data we will divide into 10 parts. 9 parts we will use for training, 1 part we can use for testing. Then we will find out the accuracy of the system. Clear? Then this process we will repeat into 10 times. By 10 cross validation I am using so that entire database we can use for training as well as testing. Clear? Then we will take a average classification accuracy of your system. RBF Kernel function, then Mexican 8 and modulated kernel function. We also need to select the parameter of these kernel function, like degree of polynomial. So if you select the parameter, then your result will change. Clear? So the correct selection of the parameter of machine learning algorithm is a problem. So what we can do, we can use optimization technique, okay, for selection of automatic selection of these parameters, or manually also you can select. Clear? So you can, here I have used four different kernel functions: radial basis kernel function, polynomial, Mexican 8 or mother wave. The impact of kernel function. Your classification strategy or machine learning algorithm also depends on the kernel function. Clear? So proper selection of kernel function or selection of parameter experimentally you can do, or you can develop your own algorithm for optimization with the algorithm for selection of kernel function. Clear? So this is I am taking example of LSSBM classifier. Clear? You can use any of the classifiers. So every classifier they have a different advantages and disadvantages. You can use 10 classification strategies. So depend on your data, which classification strategy is useful for your data, because it depends on the features. Clear? So like I have compared all these results with the previous existing algorithm. So like here we are getting 90.63, others are getting 94 or 55. So depend on the database also. So the core algorithm, these are the same database that we have compared. So here they are getting 78, 86 or 87, and we are getting 90.63 accuracy. Clear? So develop your machine learning or AI based system. Clear? So this is I am taking example for machine learning algorithms. Now another example, classification of schizophrenia. So the previous example I am taking, that is physiological classes. Now this is the pathological stage. Pathological means there is a some group or class which containing some disease. Clear? So schizophrenia is commonly, this is the neurological disorders. So as we already know about that particular schizophrenia is a neurological disorder. So brain is more responsible. Okay, brain is more affected from this neurological disorder. So that's why we have chosen EEG signal as a input to identify that particular disorder. Okay? So in this schizophrenia, 18 to 30 age group is more effective. Mostly they are affecting from the schizophrenia. This is the age group, and the 28 million people are suffering from this disorder. Clear? That data has been taken from the WHO side. What are the symptoms of this disorder? Like poor memory loss, crying without reason, speech disorder, hallucination, lack of motivation. So these are the symptoms of this disorder. If you talk about the cause, so there is no exact cause of the schizophrenia, but it has been seen that there are multiple factors, or there is an imbalance in between the neurotransmitters in the brain. Clear? So that abnormality function is known as in neurotransmitter is cause of the schizophrenia. Clear? So the database available in the Kaggle, you can find out this data set in Kaggle. So 81 human subject database is available, where 49 is belongs to schizophrenia class and 32 subjects belong to control system subjects. From the data set, they have recorded the three different conditions. One is known as immediately generated tone, listening to the same tone passively, or press a button without generating the tone. Clear? So these three conditions they have recorded data. Clear? So now that is the first question. Second, which method we should use for diagnosis of schizophrenia? Clear? So CNN you will get a multiple solution, and based on your optimization technique, the best solution you can find out. So that is the basic concept of CNN. Clear? So now which technique will give the better classification result? So the same problem. Based on the experiment, you have to find out which classification based on the experiment. to classify normal and schizophrenia EEG signals. Clear? So you can see here when I have seen the STFT and CWT and SPWT size of the features. Clear? So cooling layer will help you to regulate the overfitting of the system. Fully connected layer, that is succeed by the cooling layer is succeed by the fully connected layer. So it used for the feed forward neural network and it will convert two-dimensional features map into one dimension. Clear? And soft text layer will help you to score the probability of your data. So this is our own developed model. So here we have used 4 CNN models and 2 cooling layers. Here, so here we have to select the size of this learning parameter. So like in first we have selected 7 learning parameter size, filter size. For convolutional layer 2 we have selected 5. For convolutional layer 3 we have selected 3. For convolutional layer 4 we have selected 3. Then 2 fully connected layer I have used. So fully connected layer what will do? It will convert your two-dimensional features map into one-dimensional. Then softmax layer will take the decision or it will find out the probability. So you can find out which particular signal is belonging to which particular group. Whether it is belongs to normal or schizophrenia. So what we have found out the results. So when we have applied these 4 conditions. Here for spectrogram, scaleogram and SPWT. Here. So like condition 3 for 4 CNN model we have applied, then the accuracy was 50 to 66%. You can see here. If we are using a spectrogram, then the accuracy is 51 and 52. Even though the CNN model we also applied. Same CNN. Scaleogram we are getting 52 to 54 and for SPWT we are getting 66 to 65. Clear? So condition 2 also we are getting around 50 to 60% classification accuracy. But for condition 1 what we are getting 78 to 79 for spectrogram, scaleogram for 99 to 90 or SPWT we are getting 93%. Here or experimentally we have find out. Condition 1 provide better classification accuracy. If we compare spectrogram, scaleogram and SPWT, then SPWT is much better choice because scaleogram is given a less classification accuracy as compared to SPWT. Here, so SPWT is better choice as compared to other areas. Here, when we talk about the CNN model, so all CNN model are given are near around 93%, but our model is given 93.36. So the only change is 0.03% accuracy. Clear? So like here, any CNN model we can apply with SPWT. But when we have compared in the hardware, okay, because the accuracy was same in all 4 CNN models. So what we have done, you can see here, when we are applying BGG16, then it required 16 convolutional layer. When we are talking about LSNet 50, so it's required 50 convolutional layer. LXNet required 5, but our model required only 4. Clear? If you talk about the DenseNet layer, so they have a different size. If you talk about the filter size, so they have a different filter size. If you talk about the learning parameter, so our method is required only 1 million learning parameter, but LXNet required 61 million, ResNet 50 required 25.5 million, and BGG16 required 138 million. Okay? So based on this table, we can say that our method having a less computational complexity. So whenever we develop our method in the hardware, so we require a less memory. Clear? Our method having a less computational complexity as compared to LXNet, ResNet 50 and BGG16 at the same accuracy. Because all 4 models are getting 93.43% accuracy. But our CNN model also getting the same accuracy with the less computational cost. Because it's required only 1 million learning parameters. Others are required 61 million or 138. It's a 61 means more than 25 times. So it will take too much time when you are applying this method. So it will require lot of time. But our method requires less time. So our method is fast, computationally fast method at the same accuracy. So that's why our method is more. You can see here other parameter also I have calculated like accuracy, sensitivity, specificity, Matthew correlation coefficient, F1 score or precision. So these are based on these parameters also we can conclude that our CNN model is much better as compared to other existing models. Clear? So this is the confusion matrix. Based on the confusion matrix, you can find out how much which particular signal and which group is belonging to which class. Clear? So that is the confusion matrix. Then we have compared our result. All existing methods are available for classification of schizophrenia. So like here, we also developed some method which is decomposition based. You can see here the accuracy we are getting 88, 89, 91 in the same data. But this method is given a 93.36. This method is computationally efficient and better as compared to other existing methods. So what we can conclude here, we can conclude primarily AI in healthcare is analyze the relationship between the treatment technique as well as the patient outcomes. AI can provide you fast and accurate diagnosis. It will also help to reduce the human error as well as the cost of the treatment or diagnosis. So whenever the new database will come, accordingly you can modify your system. Clear? Like in case of some other disease, if new variant will come in the picture, then your model you can train for new database. Okay, only the parameter you need to select, but the cost will be remain same. Okay, so these AI-based techniques are cost effective. Clear? So that's why we need to apply machine learning or AI-based system, so that whenever you need to require based on the feedback, if you want to change your algorithm, so easily you can change. Clear? If you look at the future scope of this research, so suppose that if you are using a different kind of signals, so like heart having a different type of signals, like ECG, which is known as electrocardiogram, which measures the electrical activity of the heart. ECG signal, which is known as phonocardiogram, here, which measures the sound of the heart. What will be the sound of your heart if you want to measure? Then PCG signal you can use. So same BCG signal also, which is known as electrocardiogram, which use the pressure of the signal. The other signal which you can use for the like EMG signal, which use the electromyogram, which measures the electrical activity of the muscles. There are some other signal which is known as center of pressure, which measures the postal stability of the signal. Clear? So there are different types of signals are in your body, which is known as biomedical signal. So based on your problem, which particular organ you need to encounter, then the physiology of that organ you need to understand. Then you need to put the sensor on that organ. Clear? Like in my case, I have chosen EEG signal. So what I need to do, from brain mapping I have to understand where we should put the sensor in the brain. Suppose you are taking a ECG signal, then what you need to do? You need to understand the physiology of heart. So where you need to put the sensor in the heart, so the electrical activity of the heart you can measure. So that analogy you need to understand of that particular organ. Clear? So this is references that I have used. Thank you from my side. If you have any question, then please you can ask. If you have any question, then please ask. If anybody has question, then yeah, please you can ask.
So, we have questions.
If anybody have any question, then please ask.
Any questions?
Thank you, sir, for the lesson. So now as we move forward, it's my pleasure to introduce our next speaker, Dr. Suvin Kumar. Dr. Suvin Kumar is an assistant professor at the National Institute of Pharmaceutical Education and Research, Ahmedabad.
Participant can ask a question if you have any query. If you don't have query, it's okay. Fine. So thank you, sir.
Yeah, thank you so much.
For sparing the time. Yeah. Thank you so much.
Thank you, thank you.
Thank you. In future, we will hear you.
Dr. Suvin Kumar previously faculty member at the University of Delhi and completed his postdoctoral research at Tucson National Institute of Science and Technology, South Korea. He holds a PhD from Delhi Technological University. Dr. Suvin Kumar research focused on biomaterial and non-invasive, partial invasive disease diagnosis. He has published over 52 papers in high impact journals, 420 citations, and a H index of 23 and I-10 index of 32, recognized among the world's top. The warm and association welcome Dr.
ऑल्सो जो कल इस इवेंट में नहीं थे जो आज आए हैं, तो इफ यू वांट आज के इवेंट के बाद विल डू योर रजिस्ट्रेशन एंड यू विल गेट द बैग्स एंड एवरीथिंग. नहीं था. ओके, सो जब अभी 2 और इवेंट लाइन अप है, उसके बाद विल जस्ट डू योर रजिस्ट्रेशन.
Good morning, everyone. Good morning. Thank thank you, Dr. Rahul Kumar, who is inviting me for this conference. So thank you. And this is my first visit about IITR. So I'm highly fascinated to deliver talk here on my own topic, that is biosensor. Last 15 years I am working in this specific field, the chemical biosensor. And I have three different areas. First one is synthesis of nanomaterials. Second one is synthesis of or fabrication of electrode surfaces that can be used for various applications. Not only biosensor, it will also use in yeah. So it will also use in another field like battery fabrication, capacitor development, or memory-based device fabrication. So this is our second agenda. That is motto of our research. First one is synthesis of novel nanomaterials, not including metal oxide, metal sulfide. I am working in development of some novel nanomaterials, just like hydrogen substrate graphene, graphene oxide. You have to do biopsy. Okay, highly painful as you know, and site selection is very important. Okay. So to overcome these in the market by my PhD supervisor B.D. Malhotra in 1994, and already it is sold by Pulsatum and some Alpha company. So it is already in market. So okay, so this is the journey of glucometer. But what is the problem of another biomarker? It is not available in the market for other diseases like cancer. No point of care devices. Problem is there is two different problems. First one is shelf life. Have you checked glucometer strip when you are using this one? It shows 2 years shelf life. Okay, but there is some instruction mentioned in the strip is when you open the box, its shelf life is about 3 months. Okay, so what is the another problem? Shelf life should be at least 3 months because when it will produce, it will production will occur, fabricate, and when it will be used by some another subject, it should be take some time. So it is not easy to just fabricate and diagnose by some other people. So it will take some time. So at least on the basis of glucometer, we can say at least 3 months is required, and having ability to differentiate 120 milligram per deciliter and 121 milligram per deciliter. This is the concentration of glucose which is present in diabetic and non-diabetic. It is clear for you? So this specific biosensor, first one is shelf life and second one is sensitivity. Sensitivity in terms of it having ability to differentiate diabetic person with the normal subjects. So it have ability to differentiate 120 milligram per deciliter and 121 milligram per deciliter. क्या होगा when some errors will be occur? क्या होगा? Patient will be panic. अगर आप किसी को कैंसर हुआ, when you are specifically diagnosed, okay, this biomarker can be used for the diagnosis. This is specific, just like oral cancer, CIFA21, novel biomarker that can be used. It is secreted in saliva sample of oral cancer patient, and its concentration is about 3.8 nanogram per ml. नीचे है 3.7 किया, 3.9 को डिफरेंशिएट नहीं किया, ठीक है ना? What happened? पेशेंट में भी पैनिक, पता चला कि हाँ आपको इस डायग्नोज पे सब्जेक्ट इज सफरिंग फ्रॉम कैंसर, आप बोल दो कि कैंसर है और बाद में पता चले नहीं है। इससे अच्छा पेशेंट को पहले पता हो कि नहीं है, फिर वो जाए दूसरे डायग्नोज करके। सो सेंसिटिविटी इज अ बिग इशू ऑफ द बायोसेंसिटिविटी and several biomarkers. So today in one our session, I will try to sum up these all things. And here our main agenda is how to develop a biosensor based on nanomaterial for the detection of cancer. We will discuss two different cancer, liver cancer, and if time will allow, then we will discuss about the lung cancer. Okay. So some papers of some work we have done to use thread. ये है ना? खलेगा क्या बोलते हैं इसको? This type of thread we have used to diagnose cancer. So cases को modify करेंगे, how it will be used for the development of electrochemical biosensor and at what concentration it can be used for diagnosis of normal subject with the cancer. So this is the main motto. First one is we will use traditional electrode. After that we will move for the advanced stage. That paper based. So we will talk about our laboratory. So first we will talk about. Am I audible? Or not? Okay. So when we will talk about the biosensor, today's topic is development of nanomaterials based electrochemical biosensor for cancer diagnosis. So my lab is based generally work in 4 different dimensions. First one is this one, replacement of traditional electrode surfaces. Traditional electrode surfaces, that means you have to use gold electrode surfaces to development of electrochemical devices. Why? Because it is highly conducting in nature and it is highly reproducible in nature. So generally gold electrode is used for the development of electrochemical. But price is very high. When you are talking about the metron electrode system, it will take 400 to 500 rupees. It will be very difficult to miniaturize or give to the subjects or give in the market. And then its cost will be more than 500 rupees. So it will be very difficult to see a normal human being to purchase this type of strip. Okay. So main motto is when we are talking about the glucometer, its cost is not more than 5 rupees or 10 rupees. Okay. One strip cost is not more than 10 rupees. Maximum 70. It is the maximum value that is available in the market. Okay. So first one is replacement of traditional electrode. That is replacement of gold coated electrode. Okay. So with the help of what? With the help of thread. जो मैं बता रहा हूँ ये this type of thread. So we are using we have developed thread based biosensor for cancer diagnosis. Another one we can use paper electrode to replace also that traditional electrode, that is ITO electrode or screen printed gold electrode or this type of thing. So we would like to replace that specific surfaces with a thread or paper. Second one is material synthesis. When you would like to talk about the material, several applications is there is several applications. When you are talking about drug electric, when you are talking about the energy storage, when you are talking about the memory storage, so capacitor development. So there is lot of application of this specific nanomaterial. So we would like to synthesis highly conducting and having fluorescent property. If we are talking about the quantum dots, then it should be highly fluorescent properties, first one. And second one is highly conducting in nature. What is the limitation of graphene oxide? When we are talking about the graphene oxide, it has its main problem is band gap is zero, due to which it can't be used in the development of biosensors. It can't be used in the development of devices. Okay. So we would like to replace that specific graphene oxide with some other novel nanomaterials like hydrogen substrate graphene. It having band gap in 2.0 more than 3 times, three order. Okay, so when you are talking about with respect to graphene oxide, if its value is 10, then its value is 10 to the power 3, that is 1000. Okay, so the order of conductivity changed from 1 to 3. So this is the beauty of our synthesized nanomaterial. Along with this one, we are also synthesizing its quantum dot. Some nanomaterials or some quantum dots of graphene oxide is already available. But when you are searching in the Google, there is no availability of oxide of hydrogen substrate graphite. You can search. So we have synthesized this specific material and we will show here results. And you can see we can also use this specific oxide of hydrogen substrate in the synthesis of quantum dots of this specific nanomaterial. And this specific quantum dot having several properties you can use in tracking of the drug devices or in the thermia, this type of application you can use with the help of this hydrogen substrate. So second one is material synthesis. The types of hydrogen substrate graphene and graphene. So our main motto is development of some novel nanomaterials. Another one is disease diagnosis. So this type of disease to diagnose. First priority is cancer. In that one, oral cancer, liver cancer, and lung cancer. This is the 3 main priority area of our lab. Along with this, we would also like to diagnose cardiovascular disease and mental assessment. Some papers we have also published in the swine flu diagnosis and one virus. So how we can detect this specific virus or its caused disease, swine flu or this type of disease when occurs in the human being. So how we can actually diagnose with the help of development. So another work is the disease diagnosis. And last one is wearable electronic devices. So you'd like to use this rate-based biosensor when you go you wait in the morning on the basis of concentration of several biomarkers. You can see your stages or what is the possibility of disease or what is the concentration of your biomarker secreted in sweat sample, and you can analyze which type of what is the probability of disease you can subject can be occur. So on the basis of this one, we would also like to develop electronic devices. So today's topic is nanomaterial based bio. Here is we have used different types of nanomaterials and how we can increase its biosensing parameter when we are playing with nanomaterials and when we are playing with electrode surfaces. So we will use hydrogen sulfide wave band. Another one is due to lack of functional group, we would like to entail with some linker morphos, and after that when we see some limitations, then we have developed or intrinsically functionalized our hydrogen substrate wave band morpho. So the third one, hydrogen sulfide wave band oxides capacity to develop a same not only with the help of gold electrode, we can use another materials like graphene or graphene oxide. This type of material, carbon materials we can use for the development of asymptotic. Along with this one, another work is biosensor for lung cancer detection. And here we have first used Ihituaist electrode, and another one is lead-based biosensor for lung cancer diagnosis. So this is the topic today we will cover. So first one is when we are talking about the nanomaterials. Okay. So what is important? So I think you all are aware about the nanomaterials. It's a very less size, in between 1 to 100 nanometer, and due to this one, it shows a drastically changing its properties, not in the form of only chemical, also in the form of optical, electronics, magnetic, or material. So when we are compared with the bulk material, nanomaterial shows several advanced properties in terms of optical, electronics, and magnetic and mechanical properties. And when we are talking about the biosensor, so generally when we are talking about the biosensor, it is an analytical device having ability to diagnose biological concentration which is present in our sample in electronics. So this is an analytical device. This converts our biological response to an electronical response, electrical response. So there is several advantages. What is the advantage of biosensor when we are talking about this one? So first advantage, it is highly rapid. So it gives result within 5 seconds, 10 seconds, or maximum 1 minute. So this is the first advantage of this one. Second one is highly sensitive, because when we are talking about the development of biosensor, there is some interference studies also be carried out. Okay, so it is highly specific, and it is hospitalized. When we are talking about the heart attack. So if some problems you have seen in your chest, okay, heart, then first you will see, okay, what is the concentration of cardiac troponin. Okay, then we do not need any worry, or we do not go to the doctor or hospitalize. So it will come the hospitalized, reduce the hospitalized fees, or don't move from home to the hospital. So there is several advantages and there is several implications of the biosensor. Okay, so first one is you can easily see the soil quality, which type of crop you can grow in your soil. So with the help of this specific biosensor, this type of element is present in your soil, and this type of crop will be helpful to grow. So this type of things we can easily diagnose with the help of biosensor. Food quality, pollution monitoring, toxic gases, pharmaceutical and drug analysis. Along with this one, you can easily diagnose various disease. Okay, so our main motto is the disease diagnosis. And when we are talking about the component of the biosensor, there is several components: analytes, bioreceptors, biocompatibility layer, transducer, amplifier, producer. So there is several components. We are working on this specific part, biocompatible layer, with the help of nanomaterials. Okay, and another one is bioreceptor. Which type of bioreceptor you can use for the development of electrochemical biosensor. So first work is nanomaterial based biosensor for liver cancer. So when we are talking about the liver cancer, so as per WHO report, so about 8,30,000 deaths occurs in 2020. Okay, as per WHO. So when we are talking about this liver cancer, it is in top 10 disease where subject is more suffer. So there is several symptoms occurs in liver cancer. So when we are talking about the several techniques, which type of techniques is used for diagnosis of liver cancer? Main important diagnostic techniques is biopsy, and it is very painful when you are talking when we are you take cell sample or tissue sample from your liver. So it is very painful, and results come within 72 hours to 3 days to 5 days. It generally takes primary result you can observe, and this type of result you can observe within up to 15 days or 20 days. So primary result you can observe within 3 to 7 days. So this is the technique. These are the techniques that are being used for the diagnosis of liver cancer. But there is several limitations. Main important is money is very important. So generally biopsy takes 10,000 to 50,000 rupees, and then another one is painful sample collection. So these are the two limitations of this specific this type of detection technique. Along with this one, you have to diagnose or you have to do this type of experiment or this type of techniques you have to use in the supervision of any specific doctor. So these are the limitations. So to overcome this one, you would like to first, when we would like to develop biosensor, the first thing is which type of biomarker we have to select. So first one is we have to we have to review several papers, and more than 140 papers we have summarized. And on the basis of this one, we have selected only 6 or 7 biomarker that can be easily used in the development of biosensor for liver cancer detection. So in this one, when we are talking about the energy, this one last one, actually. So energy A2, then its concentration is about 1.3 to 18 nanogram per nanogram per ml when subject is normal. But when subject is suffering from the liver cancer, then its concentration goes from 18 nanogram to 543 nanogram. Yeah, 543 nanogram per ml. So cutoff value is 18 nanogram per ml. So on the basis of this concentration, and what is the another parameter? Another parameter is sensitivity 80.4 to 100%, specificity 91 up to 91%, PPV value up to 86.2%, and main thing is DA, that is diagnostic accuracy, it is more than 92%. So this type of properties can help in the selection of this energy A2 biomarker for the liver cancer diagnosis. When you are compared with the another, so diagnostic accuracy somewhere it is missing, and some specificity. So this value is higher. I think 22%. This is 94, but here DA is not reported. Here DA is 90%. So on the basis of this criteria, we have selected energy A2 biomarker for liver cancer diagnosis. So when we are talking about the which type of properties generally occurs in the energy A2, so several properties. So a specific property is it has a specific cutoff value, 18 nanogram per ml. So first work we have done is hydrogen sulfate glutarate based biosensor for liver cancer diagnosis. So first we have developed our lab have developed hydrogen sulfate glutarate oxide. So this is the 2D nanomaterials that has been synthesized having a specific 1.98 electron volt with carrier mobility 10.5 centimeters per volt. It has more than graphene oxide, due to which we have used this specific hydrogen sulfate glutarate. So generally chemical process is used for the synthesis of hydrogen sulfate glutarate, and electrophoretic deposition technique is used for the fabrication of our biosensing electrode. So there is several characterization techniques just like XRD and FTI. We have analyzed our nanomaterials successfully synthesized. So this is electron microscopy study, and this one is the some property we have investigated. So when we are comparing with the size, 2 centimeter length, 2 centimeter larger, 2D nanomaterials we have synthesized, and it is transparent in nature. When we are compared with the other nanomaterial, it is transparent in nature. So this is the video I would like. So this experiment done by in our laboratory. So this hydrogen sulfate glutarate is synthesized on the copper file. Okay. And this type of material, actually, when you will see with respect to graphene oxide, this type of 2D nanomaterials will used in the fabrication of variable or tattoo-based parts, just like you can see. So this is the novel properties we have observed in hydrogen sulfate graphite, and you can easily transfer from one platform to another platform. You can see. So this is the beauty of synthesized. Okay. So along with this one, we have also investigated porosity or porosity. We have also investigated potential, zeta potential, and its zeta potential is 12.6, and both sides 7.89. Along with this, when we are compared with the immobilization of nanomaterials on this surface, then common technique that are being used is FTIR or XPS. So FTIR is generally available in our laboratory or in laboratory. So on the basis of FTI, we have investigated that our electrode or our nanomaterials, or you can say uh, analyte bioreceptor that is antibody of energy negative is immobilized on the surfaces. So on the basis of peaks observed through FTIR, we can say our electrode is successfully synthesized. And on the basis of scanning electron microscopy, we can also say to successful immobilization of the antibody onto the electrode surface. So this is the same study, and this is the FTIR study. Along with this one, when we have confirmed, okay, our nanomaterial successfully thin film we have fabricated, antibody is immobilized on this surface, DSM molecules is immobilized on this surface. So on the basis of this, we can say our fabricated electrode can be used for the development of biosensing platform. But it will use electrochemical property or not. So first we have done electrochemical characterization by various techniques, cyclic voltammetry, differential flux voltammetry, chronometry. So several techniques we are using. Here we have used cyclic voltammetry for this study. And when we have compared with the IQ, with the hydrogen sulfate graphene IQ electrode, you can see here. So this is the value of IQ and this is the value of the hydrogen sulfate graphene. So on the basis of this one, we can say our synthesized nanomaterial is highly conducting in nature with respect to indium phosphide coated glass. So, and along with this one, when we have immobilized antibody on this specific surface, current has been decreased. This indicates our nano antibody is slightly insulating layer, and BSC also, we also know BSC is also as work as an insulating layer. So when we are deposition one electrode for the nanomaterials, another one is antibody, another one is BSC, its current is decreases with respect to another one. So on the basis of this one, we can say, okay, we have successfully synthetic biosensing platform. Along with this one, we have also done a scanning electron microscopy. So lastly, when we have observed, okay, our electrode is successfully fabricated, then we have to move for electrochemical response study. And on the basis of this cyclic voltammetry study and differential pulse voltammetry study, we can say our developed biosensing platform having ability to detect energy A2 biomarker in the range of 0.01 femtogram per ml to 1000 nanogram per ml. So this specific biosensing platform differentiate normal subject to the liver cancer. So this obtained value is also confirmed through another technique, that is differential pulse voltammetry, and it also shows similar result with sensitivity. When we are using cyclic voltammetry, its sensitivity is 13.8, but when we are talking about the differential pulse voltammetry, its sensitivity is 2.8 microampere. With limited, both shows limit of detection is 0.01 femtogram per mole. So on the basis of this one, we can say, okay, cyclic voltammetry technique is more suitable for our developed sensor towards the detection of energy A2 biomarker. So when we are calculating the number of molecules, what is the minimum number of energy A2 biomolecules we can detect with the help of our developed sensor. Then on the basis of this calculation, we can say up to 3 molecules of energy A2 we can easily diagnose through our developed sensor. So this is the beauty of our fabricated electrode. So we have also done interference study, introducible study, self-life. So several studies we have done. First one is control study. This one is interference study. This is the reproducible, and this is the self-life. Self-life is about 35 days. So this is the limitation of this one. Yes, please.
Sir, sorry to interrupt. Can we do something about this page? Actually, the content is
You can switch on.
no, sir, the content is
Content. Now we can do. Here it is okay. So along with this one, we have collected sample from liver. It is in Delhi, ILPS, and we have also developed sensor in the liver cancer patient. And here we have observed less than 10% of the 10% RSD of the developed sensor. So it is about 5.4. So acceptable value is less than your biosensor having ability to detect liver cancer within 10% of RSD. Okay. So here obtained result is 5.4. So on the basis of this one, we can say, okay, this platform can be used for the development of liver cancer diagnosis. So conclusion of this one is we have successfully synthesized 2D hydrogen. Problem is this type of devices have lack of functional load, due to which our shelf life is lower with respect to the. So at least we need 90 days of the shelf life. Their shelf life is 35 days. So what is the main issue? We don't have functional load of the substrate development, due to which there is lack of formation of between bioreceptor